Good morning. Today we will continue cluster analysis. Last class what we have discussed? We have discussed the definition of clusters. Then we have gone for some process model of clustering. Under process model, what are the things we have known that what is to be cluster? And criteria for clustering. Then what we have done, then we say that the partitioning algorithms, and also we have seen outputs. Outputs are nothing but the clusters. Okay, this is input, this one algorithm plus the measure, some distance measures. These are basically process. This is output. Then under criteria distance measures, particularly for continuous variables or metric data, I have given some of the measures like Euclidean distance, squared Euclidean distance, then your Manhattan distance, then your Minkowski distance. And then we have discussed the two types of algorithms. One is hierarchical clustering, and second one is non-hierarchical clustering. Under hierarchical clustering, we have discussed about agglomerative hierarchical clustering algorithm, and under this that we said that we will be discussing k-means clustering. And again under hierarchical clustering, particularly for agglomerative clustering, then we have discussed the different joining algorithms. For example, we discussed single linkage, which is all known as nearest neighbor, complete linkage, which is also known as farthest neighbor. Then we gone for average linkage, then centroid linkage, then there is median linkage, then word linkage. Okay, and we also discussed something called dendrogram, particularly using single linkage and using complete linkage we have described. Okay, so now we will start with this single and complete, then we will go to average, centroid, all those linkages. Now let us see this slide what I have shown you in the last lecture, that single linkage where the nearest neighbors are joined, these distance measures are considered for joining. Complete linkage, the farthest neighbor distance are considered for the two joining clusters. Centroid we have not discussed, we will be discussing today. And then average, median and word, these are also not completely discussed. Then the total algorithm I have already discussed to you, and I have also given this example in the last class, and you have seen that how dendrogram was formed. So today let us see the mathematical formulation of all those things. When we talk about that single one, single linkage, basically we talk about distance between, suppose we are talking about two groups, that two clusters are in S, then the distance will be calculated like this: minimum, that DRS given R belong to capital R and S belong to capital S. So, we have seen earlier also, suppose there is 1, 2 and 3, and on this side 1, 2 and 3, and there are certain distance, let it be this 1, 1, 0, 2, 4, and this one let it be 4, then this is let it be 2, 2, 0, 5, so then 3, 3, this will be 0. So, we first started with grouping, this is the minimum, we have grouped this. So, 1, 2 is grouped, then 1, 2, 3, this will be 0, then one more thing is coming. But if you add one more object here, then ultimately you will be getting some more values, and you have to find out the distance between these two, that this group vis-a-vis this group vis-a-vis this, then from this group vis-a-vis this point of view, the distance, minimum distance between 1 and 3 and 2 and 3 will be considered. That we have discussed earlier. And your complete linkage case, what is the formula? Complete linkage case, that DRS, it will be maximum of the small DRS given R belong to capital R and S belong to capital S. So, here when we join, we compare or we measure the distance between two groups or two clusters like 1 and 2 and 3, then the maximum distance between 1 and 3 and 2 and 3 will be considered. Okay. In case of average linkage, what it is done, it is basically taken the average distance like this. So, when we talk about average linkage, then we talk about DRS, that is the distance between two clusters. This will be sum total of S, all R, and DRS by NR, NS, where this is the number of elements in cluster R and this is number of elements in S. Okay. Now, how it will work? If I go back, you see we are saying that average linkage here. So, this is an example where 5 objects are to be grouped, and the distance measures 2, 6, 5, 10, 9, 4, 9, 8, 5, 3, these are computed using certain matrix, let it be Euclidean distance. Then your first step is, what is the minimum distance here, that is 2. So, and that is between 1 and 2, you have grouped 1 and 2, and then another matrix you have computed distance matrix like this. Now, how do we get these 5.5, 9.5 and 8.5 values? These other values 4, 5, 3 are basically 3 between 3 and 4, between 3 and 5 and between 4 and 5, that will be straight away getting from this previous matrix. Now, in this matrix how 5.5 is got? We are using average linkage. We want the average distance between the of the members of the two clusters that you are going to join. So, here I want to see that the cluster 1 and 2 and cluster 3, what is the distance. Now, the average distance between 1 and 3 and 2 and 3 you find out. 1 and 3 is 6 and 2 and 3 is 5. Now, you take the average. What will be the average? Average will be 6 plus 5 divided by number of elements in this cluster into number of element in this cluster. Number of element in this cluster is 2 and number of element in this cluster is 1. So, 2 is to 1. So, 6 plus 5, that is 11 by 2, that is 5.5. So, similar manner you will be calculating, and finally, this dendrogram can be prepared. Now, come to centroid linkage. Centroid linkage is little bit different, where here we will first find out the centroid of the cluster, and then we see the distance between the centroids. For example, let us consider R is one cluster and S is another cluster. Hypothetically assume that these many members are here, these many members are here in these two clusters, and definitely each members are measured in terms of p variables, xr, that xr1 to xrp, and xs also s1 to sp, that p variables are there. Now, that's you are finding out the mean of the variable vector here, and as well as you are finding out mean of the variable vector here, and then this is what is the mean value. How we are finding out here? You are finding out r equal to 1 to nr, that is nr, n capital R, this is the number of element in this cluster, and n capital S, that is the number of element in this cluster. Then you are finding out for each of the variable what is the mean value, that is means sum total of individual variable values up to nr observations and divided by nr. Similarly, for this you are getting this one. So, the xr and bar and xs bar, these are the vector quantity of p cross 1. Okay. Then you find out the distance between this and this, xr bar and xs bar, and this will be definitely this one, norm 2. So, xr bar minus xs bar, that is square. So, it will be x1 r1 bar minus xs1 bar square plus this minus this square plus this minus this square, this sense it will be calculated. Okay. So, this is the distance. When you are now, what will be the, suppose if we now combine these two R and S, these two if we combine, that this cluster versus this cluster, this combined means one cluster will be created and this new cluster is T, then what will be the centroid for this new cluster? The centroid for this new cluster will be that centroid, that weighted centroid of the two clusters joined together. That is why x t bar equal to n r x r bar plus n s x s bar by n r plus n s. So, then these two clusters, once it is joined, the number of clusters will reduce by 1. Again you repeat the process for remaining clusters, so long you are not reaching to only one cluster. So, you are starting with n cluster, finding out these values, then you are going to n minus 1 cluster like this, then ultimately you will be going to 2 clusters, then finally you are going to 1 clusters, and everywhere you are, when you are comparing the distance between clusters by this formulation. No, not this one, this is your average, we are talking about centroid one. Centroid case we are saying this is S square. Okay. Let us see the word linkage. Word linkage takes into consideration, as I told you in earlier class, the covariance structure. If you see this formulation, what we are saying here, we are saying this is the SSE, sum square errors. These errors are basically nothing but we are treating in this way, that as if they are this distance between objects within clusters as well as between clusters, they are the measure of heterogeneity. So, when everything is belonging to one group, that means that is completely, if it is completely homogeneous, the distance will be 0. So, in that sense the error quantity will be 0. Okay. So, it is possible when we say that all are basically forming one cluster, then you will find out this is what is the total error in terms of the distance, sum total distances. Okay. So, then we are going to what we want to find out that how many clusters that can be made. It is one cluster means lot of heterogeneity will be there, and when you go for more number of clusters, then the heterogeneity will reduce and homogeneity will increase. But when you go for n clusters, then it will be completely homogeneous, because every cluster is having one object. So, now how it works? The word linkage works like this. First you think that you have n clusters. So, here that error quantity, that distance measure is absolutely 0. Now, by you then find out that if you join any two objects into one cluster, and then what will happen, the clusters you formed, it will have certain distance, and as a result the resultant error also will increase. So, in this manner ultimately we will move, and the criteria in the movement upward is that, suppose at any instant, let it be you are here, that this is your R cluster, then this one, there will be at this point this is 1, 2, 3, 4, that 4 clusters we have formed, and in the first cluster what we are saying R clusters, there are 2, 3 and 4, 2, 4 and 3. Okay, there is another cluster here, one is, this is one cluster, then this one is second cluster, this is third cluster, then these 3 are again forming one cluster, 4 clusters, then 5 clusters are there. Now, what you require to do? Now, you want to join that which 2 clusters will be grouped together. So, as we have seen that how SSE is measured by this distance measurement, that sum total of distance. So, then you can find out for the earth cluster, here there are 3 objects, what is the SSE, that each point minus its centroid value. Similarly, for other, if you say S is this one, then you can find out what is the SSE value. It all depends, if there is only one object in a cluster, that SSE will be 0. Now, if I join R and S, ultimately what will happen? For example, if I consider S is this one, fifth one, then the resultant cluster will have 2, 4, 3 and 5 these observations. So, this resultant clusters, if I say it is T, then what will happen? You will find out SST considering 2, 4, 3, 5, these 4 objects distance, sum total of this. Okay. Now, what will be the centroid of this? That means what I am saying, you are joining R and S2 clusters, then you are getting this SST values, and also the centroid of this cluster can be calculated like this, what we have seen earlier also. Then what we will do? Basically, you have to find out that how many clusters are there. Then you will find out for every 2 clusters, if there are n k clusters, then KC2 combination you will get. For every combination, you find out the SSET. Then you see the join those 2 clusters for which SST minus this is the least. That means what we are trying to say here? I have, so for example, I have my, this is my data set. Now I am creating one cluster here, another cluster here, like this. Okay. So, if I say this is my earth cluster, this is my east cluster, then I have SSER here, I have SSES here. So, if I join these two, I will get SSET for these two join cluster joint, these two. Now, you can join this versus this, you can join this versus this versus this. So, there will be several 1, 2, 3, 4 C2 combinations will be there. Then you find out for each combination what is this value. You join those two clusters together for which this is the minimum. Okay. Then we go to the totality. What I mean to say, there are, you see, we have seen single linkage, comparative linkage. So, different way of joining for hierarchical clustering, and these all combined together, there is a formula, this D R P plus Q, that means R and P plus Q we are joining here, then D R P, suppose that means R P Q 3 clusters, you are joining P and Q cluster. Then how do you get this distance for R and P plus Q joined together, that is another cluster, this is the case. So, now choosing appropriate delta 1, delta 2, delta 3, delta 4 values. So, you will be able to apply or any of the joining algorithms what we have discussed so far. If you want to use single linkage, delta 1, delta 2 will be half, delta 3 will be 0 and delta 4 will be minus half. If you want to use complete linkage, half, 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 only delta 3 is 0. If you go for average linkage, this is the case, delta 1 is half, delta 2 is half, then delta 3, delta 4 is 0. And similarly, if you want to use centroid linkage, this NP by NP plus NQ, this one is N subscript P. Then NQ by NP plus NQ, like NPQ, these are the values for different this one. Okay. So, similarly word linkage you can find out. So, if anyone is interested to develop program it, then this is a very good formula, and then just by changing the delta and all these values, you will be able to get the clusters using all the joining algorithms for hierarchical clustering. Now, I will show you that suppose you want to use this in the sense you want to run SPSS for clustering. So, how do you go about it? In the last but one, I think in few classes I have shown you how to run SPSS for different models, and this is the flow chart for running SPSS for clustering. You open SPSS, go to analyze, then select classify, select hierarchical clustering, then you select variables, that we have given one example, that MIS, MSS and MEDS, that mean incidence score, mean severity score and mean equipment damage score. Then there are many statistics available, agglomeration schedule, proximity matrix, means agglomeration schedule means starting from n cluster to 1 cluster, how it is moving up, that is the agglomeration schedule. What are the proximity matrix, and then you can select plot, dendrogram, and there are other plots, if any you want to available, you do this. Then you have to select the cluster method, what type of measures it is, interval or other measures, because if your data is not metric data, suppose you are going for non-metric data, then what will happen, the distance calculations will be different. Okay. If there is binary data, the distance will be different. There will be maybe multinomial data, So, I think there are certain techniques for handling categorical data. There is another one technique is there, multidimensional scaling. There categorical data handling also is done, but in clustering it is possible. There is one I think that Mod-01 is one algorithm is there. One is the mean linkage, a median, but similarly Mod-01 linkage is also there. So, similarly other linkages are there. So, for example, if there is a contingency table, then your chi-square distance you can use, So, cluster analysis requires distance. So, if you can measure, you first have to know that what is this the variable vector and individual variables, how they are, how they are measured, when is their scale of measurement, and if it is continuous, fine. If it is not metric, that means non-metric data like your binary, your multi-category, in that case suppose you are using contingency table, so you can go for chi-square distance. So, you have to find out some way or other the distance. Once you get the distance, then these algorithms are applicable. Okay. Then once you click OK, ultimately I think within a second probably, depending on the memory available, you will get the result. Now, I will show you the result here. See what we have done, that screenshot cluster analysis, we have gone to analyze, then we have gone to classify, then hierarchical cluster. See, there are two steps cluster, k-mean clusters, hierarchical clusters. There are tree and discriminant, these are different technique. Then there is nearest neighborhood, this is also different technique. Then once the final click is made and we got this type of diagram. One, this is your Euclidean distance matrix, this is what is dendrogram, this is also dendrogram. The difference between this and this is here distances are equal, distance are given, is scaled, and here we are talking about similarity. So, if I see that at any instant here, suppose I take this point 81.86, then if I draw a horizontal line with respect to this x axis, then you will find out some intersection, for example, with vertical lines, this is 1, 2nd, 3rd, 4th, 5th. No, this is the border, so 4th, 1, 2, 3, 4. So, that means at 81.86% similarity level, you can keep 4 clusters. From dendrogram, you are able to find out this 4 clusters. But if you are not happy with 4 clusters, you may be interested to have your 2 clusters. Then what will happen? 2 clusters, where 2 clusters are formed? This is the case. Okay. And then if you want x1 cluster, so this is the case, that is 45.57. So, how the similarity is calculated here? Similarity is calculated using this formula. Formula is similarity, suppose S, if I say Ij or Rs, if you write Rs, then 100 into 1 minus dRs divided by the Dmax, where Dmax is the maximum distance available in the original matrix D. So, that similarity measure is there. Okay. Now, go to that complete linkage case. First one is single linkage, second one is complete linkage. Is there any difference in dendrogram? I think there is difference, because the joining pattern will change, and yes, you see here after 2 4 is joined, 2 4 3 joined, but here you say after 2 4 is joined, okay, 2 4 3 joined, then 5 joined, two 4 3, but here 1 joined, that is the difference. 2 4 3 joined, then 1, then 5. If I go like this, then 2 4 3 fine, but 5 joined next, then 1. You see, this is the joining. Okay. Now, if you go for average linkage, is there any difference? Yes, again difference 2, 3, 4 are coming together here, means one after another, but then 1 coming and 5, that means this in term like single linkage this side, and this side may be joining may be different. Okay, but whatever may be the that linkage or method you used, ultimately the clusters, number of clusters and similarity measures, these are two important criteria. You cannot go for one cluster if the similarity measure is drastically reduced. If that there you have to put a cutoff, that how much similarity, that means homogeneity you are going to accept. Okay. Now, I will explain little bit of that similarity part as well as scree plot, incremental R square and pseudo R square, what I can say pseudo F also, because these are the criteria for keeping or finding out that what will be the number of clusters that you want to keep. Okay. As I told you that similarity measure is this, so definitely we want 100% similarity, but that is possible only when you treat each individual object as a cluster and 100% will be there, and then you are basically slowly joining and then you are making your cluster like this. Maybe at this level you are having maybe 70% similarity. Are you happy with 70% similarity? Is it okay? It is fine. Okay. So, the second one is your scree plot. Now, scree plot, I think you all understand at this point in time. The scree plot we have used in PCA as well as in factor analysis. So, that means here also the structure almost that the concept is almost same, that we want to here in PCA we try to find out what will be the number of components, in factor analysis what will be the number of factors, in cluster analysis what will be the number of clusters. Okay. Then how do you do it? You do find out the scree plot like this. This side you write the number of clusters, and this side you write down the distance. Now, your cluster can be 1, cluster can be 2, like this you have n cluster. When you have n cluster, the distance becomes 0, because 1 cluster is. When what you are doing, suppose here is n cluster, then you are creating n minus 1 cluster, then you are creating n minus 2 cluster, like this you are creating say this cluster. So, if I say this is my dn, this one is dn minus 1 and this is dn minus 2, like this d2 and d1, definitely d1 will be the maximum. Now, what will be this distance? It all depends on which linkage method you are using. If you use the single linkage, that means the minimum distance amongst the member of the groups. If you use complete, that is the farthest linkage, that will come here in this side. So, then let it be that when we are, as I told you, when there is one cluster, definitely this then then what you do, your cluster number 2, for example, let it be here, cluster number 3 cluster here, maybe after that it is like this. Okay. So, I can say here may be the point which is the elbow. So, if I have appropriate distance measure, then only you will be able to do this, and then elbow this says that when the as far as the distance is concerned, now at this point what happened, after that the distance is almost parallel, means not improving much. So, I can say 3 clusters can be kept. And you have seen in my the distance part, I will tell you, because there is the issue. I think here you can understand now. When we are going for this that no that 5 cluster 0 distance, when you are going for 1 cluster it is 6 distance. So, it is from the single linkage. If from comparative linkage, the distance is changing. So, in this manner you have to know the distance while you are joining, and then you find out. Then next one is incremental R square. Incremental R square. What is happening there? Basically, all of you know a R square in regression. This one is SST minus SSR by SST, that is sum square total minus sum square regression by sum square total. Here what we are doing, here we are assuming like this. Suppose I have group of objects like this, and when you are treating one cluster, then what is the SSE? This if I say the total, then this one is I equal to 1 to n xi minus x bar its square. Okay. Now, suppose you are going for generating k clusters like this. One, two, three, four, 5 clusters. So, k clusters. So, this is my, suppose this is the kth cluster. Then I want to know what is the SSE for this kth cluster. My SSE for this cluster will be sum total of I equal to 1 to nk, the number of items there. Then you write down xi minus xk, or you can write xik minus xk par here. So, as there are k clusters, so ultimately if I say that SSE the total capital K, then this will be k equal to 1 to capital K SSE small k. Okay. So, as you have created k clusters from 1 to k clusters, so ultimately what will happen, this will reduce this one, now from this one change to this one, and using this feature that as if the regression, the what way that it will reduce the difference between the predicted versus original. In the same manner, we can create R k square, which is SST minus k SSE k. I think we will write here SSE the way we have written here, SSE for t, divided by definitely SS Then what you can write down this one, this is basically T, we are saying this one is T minus this same thing K SS E K by T. Okay. So, what will happen ultimately? Ultimately your R K square will be 0 when this quantity equal to T, and as you go on increasing the cluster, that this value will change. If you decrease, this value will change. So, ultimately what you want here, you have to find out the incremental change. If I say, if I go from K to K minus 1 cluster, then this change is R K square minus R this, where R K square or R K minus 1 square will be computed using this formulation. If there is sharp change, sharp decrease, let it be, then what will happen? When there is sharp change, that means that may be the point where we can stop, that this many clusters required. Okay. Now, using this concept, similarly you can use F test statistics. I think in regression we have used F is MSR by MSE, and that one we have used that SSR by degree of freedom by SSE by degree of freedom. Here also you can say that pseudo F, which will be T minus sum total of K SSE K by K minus 1 divided by sum total of SSE K by N minus K. Okay, this is your pseudo F, similar to F statistics used in regression equations. Why pseudo? Because ultimately the distributions is not known. You are in a group, there are several individuals, so that what distribution, joint distribution they will follow, that is not clearly. Is it multivariate normal? If not, then how can we say that this will be followed F distribution? So, that is why we are talking about that pseudo F distribution. Okay. And it's similar manner you have to decide decide the number of K. Then we will come to another important algorithm, which is known as K means algorithm, which is coming under non hierarchical clustering. K means we will be discussing now K means. So, if I just read out, then you see that the steps, there are 8 steps totality. Identify the variables, collect data, select similarity or dissimilarity measures, obtain distance matrix. This can be said that is the obvious thing that is required. Then partition the objects into K initial clusters. What you are doing here? You are basically arbitrarily setting some clusters. Then proceed through the list of objects, assigning an object to the cluster whose centroid is the nearest. Recalculate the centroid again, and then repeat this process until no more assignment take place. How do you do it? I am showing one example. You see this example. Here there are 4 objects A, B, C and D, and you are measuring using 2 variables x1 and x2. Now, the values, the coordinate values, I can say for A 5 3 minus 1 1, 1 minus 2 3 minus 2. Okay. So, if you see pictorially what is the point is, I have x1, x2, my x a is 5 and 3. So, 1, 2, 3, 4, 5, 1, 2, 3. So, this is my a. Where is my b? B minus 1, 1. So, it is minus 1, then 1. This is your b. Then c is 1 minus 2. So, I can say 1 and minus 2. This is my c. Then d minus 3 minus 2. 2, 3, 1, 2. It is d. Fine. So, I want to create possible clusters. What we will do, you arbitrarily put the objects into clusters. For example, we can do, so okay, we may say these two one cluster, this is another cluster. Then essentially what you are doing, you are basically making AB one cluster, CD another cluster. Okay. Then you have to find out the centroid for x1 and x2. Okay. Now, what will be the centroid? You have to, because A and B, these two are there. So, A is x1 coordinate plus B is x1 coordinate divided by 2. So, this one is 5, 3. So, if I write further, this is my 5 and 3, this one is minus 1, 1 and C is 1 minus 2 and D is minus 3 minus 2. So, 5 minus 1 divided by 2, this will be 2. Similarly, 3 plus 1 by 2, this is 2. Now, what is the centroid here? Here 1 minus 3, that is minus 2 by 2, that is minus 1. Then minus 2, this minus 2 minus 2 minus 4 by minus 2. Correct? This is arbitrarily you are doing. Then what you have to do? Then you calculate again that for all the things that A, B, C and D, where they like, are they truly falling under A, B or C, D? B, C, D. Then A, B is there and C, D is there. Now find out the distance between A and AB, A and CD. Now A is 5, 3, AB 2, 2. So 5 minus 2, 5 minus 2 square plus 3 minus 2 square, that means 3 square plus 1 square, this is 10. So this one is your 10, distance is 10. Now if I want this, then 5 minus 1 minus 1. So 5 minus minus 1, that is 6. So 6 square, 3 minus minus 3 minus minus 2, that means plus 5 square. So this is 36 plus 25, that one is 61. So then you compare which one is higher, CD is higher. So definitely I am considering comparing A's position, where it should go to AB, it will be in this group or in this group. As AB less than AB and A distance 10, which is less than the distance between A and CD 61, so its group should be AB. Similarly, if you compute for B versus this will be 10, then this will be 17, this will be 45, this will be 9, this will be 4, this will be 4. And if you compare now that this should come under, B should come under CD, C should come under CD because these are the lowest values, and D should come under CD. So accordingly, and it is also, it is quite obvious, because if you see here, you see this is quite far away, compared to, even if I compare B and D, it is nearer than A and B. So, our new cluster is like this one and this one. You repeat this, then find out. Okay, let us see what happened here. So, new cluster A, B, C, D, and you are finding out the centroid here, and then again you are comparing that the distance between A and the two clusters formed, distance between B, two clusters formed, and in this case you see. So, ultimately A belongs to cluster A, but B, C, D, when B belongs to cluster B, C, D, C belongs to cluster B, C, D, and D belongs to cluster B, C. So, no more clustering is required. Okay. So, that means for this data set 2 clusters are enough. That is what K-means cluster. Now, if you want to use Minitab for K-mean clustering, then you go to Minitab, go to Stat, select multivariate, select clustering K-means, then you select variable, enter number of clusters, click this storage, this will be storage, and then click OK, you will get the results, and this is the snapshot. This is what cluster 1 and 2 for the data. This is not the example data what we have just solved here, but the data safety data, MIS, all these things. So, ultimately you are getting 2 clusters, 5 observations each in clusters, and they are weighted that centroid sum square and average distance, maximum distance, these values all are you are getting. Now, you have to appropriately interpret the values what you are getting for different parameters. Then I am showing here that the cluster membership A, B, C, D, E one cluster, cluster 1, P, Q, R, S, T cluster 2, while we have generated data, we have generated from 2 clusters, and we are now finding out, that is why A, B, C, D, E and P, Q, R, S, T 2 different ways we have named, and ultimately the distance is coming, and you are getting, you have got 2 clusters with the distance like this. This is the final clusters combinations, here 5, here 5. This overlapped are there, so that is why you are not able to see. Now, I will show you within 3 minutes of time one case study. The case study was conducted on a large integrated steel company. Data was collected for the past 1 year. In total, there are 175 departments, and we have analyzed based on mean injury potential scores and mean equipment damage scores to understand the hidden structure of the data. The sole purpose of this case study is to group departments with similar features, so that safety initiative and resources will be put accordingly. Now, we have used multivariate clustering K-means using Minitab, and these are the snapshots, and this is what is result. We found that 175 this one can be, the departments can be grouped under 59 clusters, not 59 clusters, 5 clusters, and number of departments under each of the cluster is given, cluster 1 26, cluster 2 28, like this. So, we from 175 to 5 reduction is enormous, and because of this much reduction, definitely there will be similarity problem, but in K-mean clusters that similarity, that Minitab is not, has not given, but the method procedure we have discussed, we can find out. Now, see the plot. If I see the from average injury potential, equipment damage score, and as far as the membership cluster number is concerned, you are getting this type of picture, but please find out, see the remember what is happening here. There are so much of overlap, and it is quite obvious, because you may not get that clear crystal clear the demarcations unless the nature is like this, the department are such that there is a distinct difference, but in the safety performance point of view for this, yes, these are the departments which are absolutely different from these other department. Similarly, these are the department which are basically performing, this is the 0 point, that is the performing, 0 is this one and this one. So, this is 15, that is average performance here, average level they are performing here. But here this quadrant, this is really a complicated one and very much what I can say important also, because injury potential and equipment damage score both are higher in this job. So, now management may see this result and then find out that no, this cannot it will be on one clusters. So, then you will reduce the cluster, but when you reduce the cluster, similarity will be lost, means your homogeneity will reduce. So, that also you have to consider properly, and then you have to decide on that what you will do, how many clusters you will keep, some clustering, selection of clusters, some multivariate statistics nowadays available, but it is again in the research domain and difficult. Then finally, conclusion that cluster analysis is very useful and widely used technique in grouping unstructured multivariate observations. Several algorithms are available, and so the analyst must choose the best one for the data. The case study reveals that although the company has 175 departments together, from safety point of view, these can be grouped into 5 groups. The safety initiatives and resources can be taken accordingly. Okay. So, I will just summarize that what we have learned in cluster analysis. Your data set is like this. You have several characteristics features. You want to group the observations. This is our purpose. Then what we have discussed, that we require certain criterion to group. This is distance measure. There are many distance measures. Suppose you have metric data, you have non-metric data. Metric data Euclidean, square Euclidean, Manhattan, Minkowski distance, and categorical data chi-square distance. Then your in binary case several combination of distances, several distance measures are possible. Follow Agresti. Once you know the distance, you require to know the partitioning algorithm. This can be hierarchical, can be non-hierarchical. Hierarchical is that agglomerative hierarchical clustering, and here K means clustering. Here there are several linkages starting from single, complete, average, centroid, then word linkages. Here it is basically K means is heuristic one, and it one basically it arbitrarily group and then work like this. Now, in hierarchical case, things started from n clusters, then moved n minus 1 to 1 cluster, and in this process you create dendrogram. In this process you create dendrogram. Dendrogram is a very useful pictorial representation which will show you that how many clusters and how the agglomeration process also takes into account in this algorithm. And this side will be the similarity measure. That similarity measure will tell you how to go about, what will be the number of clusters. There are some other way of doing things, I said that scree plot you can use, you can go for that incremental R square, you can go for pseudo F. Okay. And ultimately the cluster analysis is really very helpful and useful tool, but all depends on the quality of data and the analyst knowledge for the purpose it is used. Keep in mind this, because your brain should not be replaced by the statistics only. Thank you very much.